So, welcome. First of all, my question, who of you wants me to give this talk in English as it is announced? So who doesn't speak? Oh, perfect, no problem. So you have to live with my crabby English. So my name is Roland Huss. I'm coming from Red Hat. I'm a software engineer there. And I'm working in the so-called Fabricate team where we are doing tooling for a microservices platform around OpenShift and Kubernetes. But now, today, I want to talk about something different. On more general terms, I want to show you about creative ways how you can create Docker images. So this talk is called Docker Container Loading. And here's our road trip for the next hour. I started to prepare this talk, and I have also, if you have read the announcement, I've talked about to give you some live demos, but then I found one way, another way to create images. So there are a lot of ways which we develop on our own. But at the end, I had now maybe 10 or more recipes how you can create images. So at the end, I had to decide whether to go into details for some of them or whether to give a comprehensive overview of all of them. So I decided for the later. Hope that's fine for you. Okay, but now let's start. First of all, the canonical way how you create Docker images these days. So this is the official recommended way how you do Docker images. There are two ways. One of them is more recommended than the other one. So the first one is simple, that you take an existing container, then you run a Docker commit on it. So here the container D, and afterwards you give it some tag, and then you have an image. And from this image you can create other containers as well. So this is a very easy way to do it. Of course, it's not recommended at first because this is something which is not easily reproducible. Because you know the container can contain anything, and you can work on it, can create it interactively some stuff, and then if you commit it and you make an image, then it's hard to recreate this very image again. Therefore, there's a different way. It's based on Dockerfiles. You see here the content of a Dockerfile, and you use Docker build for creating these images. And of course, all of you know these Dockerfile syntax. It's quite easy. It's only a handful of keywords used here. You base all your images on a base image. Then you have some commands maybe to run to create some extra stuff within this container. You add some metadata, like exposing certain ports, for example, and then at the end you tell them what is the command which you want to run if you start the container. So you can use their entry pointer command. So this is really something, quite common. And the question now is, of course, why is this not enough? So why should I consider other ways to create images? The reason is that there is some problems. I come to this later. But what I want to show you is maybe some newer feature, which probably you already also know. It's that you can put some sort of parameter within the Docker file itself. So this is something Dockerfile, you see, it was a plain text file. You have it, and you can create the image. You can recreate it the same way. Of course, I just go back one slide back. If you do something like this, like get update, the reproducibility of your image is also limited again, because you get the content of the package repository at the time you run this image, of course. Yeah. So if you run it once and then 2 weeks later you get different packages maybe there. This is also something you should take care of. And if it's important for you that you may have a reproducible image, then you really should pin the versions of the stuff you are installing. Okay, but Dockerfile args is a simple way for putting parameters in the Dockerfile. So you can simply declare them here with an arg directive. Then you can refer to these arguments, and at build time you can provide the value here from the outside. This is quite easy. However, there are some limitations. You cannot use such parameter in the from part. So you cannot parameterize your base image, which might make sense, for example, if you're building images for different architectures, like for ARM or for Intel, and you want simply to have different base images, of course, then you maybe want this one. So we already hit the first limitation here. But there are other problems. One of the biggest problems is if you make many images, so if you create many similar images, you might want to reuse certain parts of the Dockerfile. So what you actually want is to have some sort of include, or something like composition. So you have maybe some certain parts, like for example, your run scripts always look the same, but you need some extra stuff copied over into your Docker image. So these things are not really solved with normal Docker files. And the solution nowadays is that you simply copy and paste it over and over again in Dockerfile things. Then the parameterization is a little bit simple, so you can only replace parameter values, but maybe you want to have more complex structures to be replaced, or even want to execute certain kind of code if you want to create the images. Another problem could be that you actually don't have any influence how the layers are created, so you have to know that every Dockerfile, every command in a Dockerfile creates a new image layer. And this layer is simply, it happens. So you cannot say, okay, I want to start here, then I want to execute certain commands, and at the end, when I've maybe an AND keyword, and say, okay, everything in between should go in one single layer, so that you can optimize your stuff. There's, for example, one very famous issue with Docker itself, that you cannot add, for example, files for a specific user. So everything, if you run add, it always runs in the context of the root user. And then the solution, what Docker proposes is, okay, then you run afterwards simply a run, change own, or change mod afterwards. But this creates an additional layer, effectively more or less doubling the size of your images. Because in one layer you have your files with user root, and the other one with the user you want to have it to. Okay, so this is one problem. Then the feature set is a little bit, let's say, limited. You have, okay, the syntax itself was fixed for quite a long time. So with 1.12 there was a new keyword introduced. It's called health checks. But otherwise it's simply stable. Another problem which might occur happens to you is that or might be an issue, or maybe not. It's security, because if you run the build itself, it runs always at the user root context. You can change the users while you're building the images. Of course, you can, at the end of the image, you can say, okay, this image should run then for example, as a fixed user. But the build itself runs on root context. And if you have a shared system where you build many images, then this could be really a problem. So, okay, now let's see what solutions are there for these problems outside of the Docker universe. First of all, there are some mechanism which is used by several tools, which I named Dockerfile template. And this simply means that Dockerfile is a plain text file, so you can simply use a template engine for that one, of course. And the idea is that you have a template, you fill the template, and you create a valid Dockerfile afterwards, and then you can use all the other Docker mechanisms to create the images afterwards. We have already seen a simple template mechanism already built in, but there are other engines which provide more sophisticated features. You can, if you Google for it, you find a lot of them. I will show you one of them, which is actually the one I have written. So it's maybe it's a natural choice. It's called fish pepper. So, by the way, just in case you're wondering where the name is coming from, fish pepper, I typically, if I have the chance, I typically always name my open source projects after some sort of chili brands. So this is, I'm chili pepper freak, and I grow chili since 7 years. I have another project is called Cholokia, which is also maybe known for, it's used for JMX monitoring, for monitoring of Java-based systems. Okay, what's special with fish pepper? As I said, it's a template system. It's based on Node.js, so it's written in JavaScript. And it allows for so-called multi-dimensional parameters. To explain this one, maybe I step back a little bit and explain my use case, what was the reason for creating fish pepper. I'm responsible for a whole set of base images, for Java base images. And these base images are very, very similar, but differ for certain parameters. For example, I need to have base images based on different operating systems, like Alpine or CentOS. Then I want to have base images for different Java versions, 7 and 8, and even for different types of Java, JDK and JRE. So if you take this into consideration and you have 2 base systems and 2 parameters and 2 versions, then you end up with 8 different kind of builds, so in all kind of combinations. And if you do this natively, so if you start with a Dockerfile and we started that way. We take Dockerfile, we copy it over 8 times, and then we change something, then we had to change it in 8 other things. Of course, That's a perfect use case for a templating system. We see it in some example in a minute. Another part, what Fishpepper does, it's a part so-called fragments. This is the sort of include things for reusing things. So for example, we have a fragment for the startup script of Java application, so it's a run.sh. And it's not only the part in the Dockerfile which could be included, but also the things which this snippet includes themselves from the Dockerfile. So it's a snippet, Dockerfile snippet, plus additional files, which then simply are part of the Docker build there. So this is quite nice. So you have a sort of block, as it is called in Fishpepper. Yeah, and then you can also do build and push directly from within Fishpepper. And here's an example for such a configuration. So we have here, it's in YAML syntax. You define the kind of parameters you have, except case you have base, version, and type. You give them, you have name, you have some sort of metadata which you can reference directly from within your Dockerfile templates. And here in this configuration part, you have, you see here you have for version, type, and base different sections. And then you have the different possible values which you have for these parameters. And what Fishpepper does in that case is simply iterates over all permutations of all these parameter values. So for, you see, you have here, so you have the same named variables which you refer in your Dockerfile template, but the value is different depending on the iteration you're in when it's running. A Dockerfile template looks like this. So you have, this is a I think .js, it's a templating system from JavaScript. It's quite powerful, so you can put in there arbitrary JavaScript expressions, so you can have logic in there. It's, for such a use case, it's perfect. For other use cases, it's not so perfect. And then you have some sort of main context, you have FP, and then you can refer all to this metadata. For example, this base from simply is the actual value of the base image. And the result of this is you run Fishpepper on this on this template plus the parameterization values. You end up in a directory hierarchy, something like this. So you have here the base system, you have here the version, and then the type. And you see that not only the Dockerfile could be replaced with templates, but also something like a README. And you see that every of these README are very similar, but all the parameters are filled in differently. So, what are the advantages of this approach? First of all, it's quite simple. You have some text files, you have some replacement. Of course, you need to dig a little bit into the configuration syntax and the templating syntax, but otherwise it's easy to grasp. It uses, at the end, it uses Docker build-in mechanism. So at the end, we have a Docker file, and then you can start. You can put this on Docker Hub. You can, for automated builds, you can put any other tool which works directly with Dockerfiles. You can use this now then directly. And it's, of course, it's perfect for many similar builds, especially base images. So if you're responsible for base images, maybe something like this would help you there. Of course, it's, again, you have still, at the end, you have Dockerfiles, and you cannot do more things. Okay, this was the first, our first station. Now simply to something completely different thing, which is called Ansible Container. Ansible Container is an open source project. You find it on GitHub. By the way, I have all the links, and the slides can be available online. I'll show you the link at the end of the talk. And the idea of an Ansible Container is quite, it's that it builds all the Docker images, but it builds it with Ansible, and not with Dockerfile. So this is a Dockerfile-less build. And you can manage multiple, sorry, this is not tools, multiple images at once. It's quite easy to set up. We see an example in a second. And the good thing about Ansible is that it's not very intrusive in creating these containers. Just in a second, it's get probably more clear. So the setup is a set of files. You simply call Ansible -container is a command line tool. You call Ansible -container init, and then you get something like this. This directory layout. There are some main files, container YAML there within this container YAML, which really looks like a Docker compose file. You will see it in a second. You simply start up the containers. Then you have your Ansible playbook. So Ansible itself, for those who don't know Ansible, it's a content management and configuration management system. Sorry, and it has some concept of playbooks where you simply declaratively declare what you want to happen on your host. it works also with roles. So within the playbook, there are certain references to roles which are stored in an additional directory, and then you can add some extra requirements for Python libraries or even for your roles, which can come also from an external repository. This container YAML looks like this, that you have some, if you know Docker Compose, it looks quite similar. You have some sort of services, you have give the services names. Here you have a service Django, we have a service Postgres, and we define certain images. So this is, looks a little bit like a Dockerfile, but this is a description of the base container which is started before the Ansible scripts, the Ansible playbook is applied to these containers. Well, the main YAML here is very, very simple. So you have a version, you have a host. So Ansible container simply creates for each service reference in this YAML file before an inventory, Ansible inventory with some host, and this host is Django, and that says simply, when the container Django is running, then apply this roles onto this service. So now maybe a little bit better how it works. So first of all, Ansible container starts up the base containers. These are the containers defined in this container YAML file. And then it creates on the fly an inventory with these host names, Django and Postgres in our example here. And then it runs Ansible playbook, which is the Ansible command line tool for provisioning to these already running containers. And the nice thing is it does it not by doing it per SSH, which you would do normally with Ansible, but it uses Docker exec and Docker copy to get into the containers. So there's a dedicated Ansible connector, which can be used for going into the containers without leaving any trace afterwards. So and this is also, by the way, also the good thing about Ansible in comparison to Puppet or Chef, that it's agentless, so that the only prerequisite which you need is to have some sort of Python on your containers. So this is important. Okay, and then you run your Ansible playbook for provisioning, and afterwards you stop the containers, and then comes this commit, which I showed you in the first slide. It simply really creates a new image from this container after it has been provisioned. And the good thing is here is, of course, that it's reproducible, because you can always replay the Ansible playbooks on these containers. So if you run this thing again later, you get the same images if you do the right things in the playbook, of course. But it's really, this is so the drawback of not being reproducible with commit is simply solved by this approach. The advantage, of course, is that it's very flexible, that you can reuse your existing Ansible roles. So if you're coming from Ansible already, it's a quite easy way to create images out of this. At the end, you have a single layered image. So this is also good for base images, because this commit happens at the end, and this commit simply creates one single layer. Of course, on the negative side there, it's a little bit, it's more complex. I found out that the builds take much longer because all the logic is happening there. And of course, single layered images are not always a positive thing, because it might be that you want to have really multiple layers, simply also for caching things and other stuff. There's currently no solution with Ansible container for this one, but they're working on it. So there could be that there is some sort of, that you can set some sort of stop points for creating images during the provisioning. Okay, this is Ansible container, quite nice approach. It's open source, it's on GitHub, and you can use it probably if you're an Ansible fanboy, then it's the right thing for you. Something similar now to the next station, it's the so-called Packer Docker builder. So Packer, maybe most of you probably might know them. Packer is a tool from HashiCorp, so from the same company who also created Regran and other tools. And Packer's task is to create machine images. And machine images means, for example, VirtualBox machine images, or AWS Army images, so images which can be run on a certain platform. And there's one builder which is also, it's a Docker builder which creates Docker images. So you can use the same setup, but simply exchanging the builder for creating VirtualBox or real virtual machines and Docker images. And this approach here is similar to the one we have just seen. So you start some sort of these images or container in the Docker case, then you provision stuff on it. This can be Ansible here as well, but it can be also all the other provisioners which are supported by Packer. shell is an example for here. And then there's a post-processor step, and in the Docker case, you simply do again this commit step. So it's quite similar from the approach like the Ansible container thing, and it's quite nice, and it also supports much more systems here. So here's an example for the configuration for Packer. You define there are different sections for the different parts. So one of the builder sections you give in that you want a builder of type Docker, and at the end you get some image tasks. So you can provide either here in text, and it really will create a tag on your Docker host, or it exports the image tar itself in the file system. Then the next thing is what you want to provision. Here again in this example I took it's again Ansible, but it could be any other configuration management system. And at the end, we have here Docker import, which simply takes this image tar, which has been created after this step, and imports it and creates a new Docker image there. So it's quite simple. It's easy. The advantage, of course, is it's easily reusable also for other image types. This is quite nice. You have a lot of ways how you can provision within these containers, and that's all perfect. A not so good thing is that the metadata information is not configurable, or let's say you cannot set the metadata during this build. There's no things like expose or like specifying the startup command of the image afterwards. So this is something you need to do after, in retrospective when you have created the image. Ansible only works via SSH, so there's not this fancy thing with Docker exec and Docker copy to come into these containers. And there's no caching at the moment, as far as I see. So this is nice. So what you can do for this meta information, of course, you could simply say, okay, I create an image with this approach, and afterwards I have a simple Dockerfile which has a from line with a reference to this image, and then I add all the metadata afterwards so that I have the metadata simply added at the end and get an extra image. Okay. So next step, as I said, these are more or less a series of Ignite talks, I guess. Yeah. So they're not very loosely coupled. There's a tool called Rocker, which is something I really simply stumbled upon when I did the research for this talk. And this is quite nice. It's an extension of a Dockerfile. So you have it's also backwards compatible. So a Dockerfile is actually workable under Rocker, but it adds some extra keywords to the Dockerfile syntax. So you have some extra stuff which you can put into your Dockerfile for creating, for having some extra features. One of them is multiple forms. I know that Docker nowadays supports also multiple forms. The nice thing with Rocker here is that you have, so multiple forms means you define simply multiple images in one single Dockerfile. And, but you have also export-import capabilities. So you can say the first image I want when I build simply creates or runs in Go compiler, creates in Go binary, and I want to have this Go binary copied over into the next image. So you have an export-import thing. Then you can also have a mount keyword for mounting certain things during build time. This makes sense, for example, if you're a Java user and you have Maven, then it really makes sense to mount in your Maven repository, your local one. Otherwise, every build would download Maven afresh, the Maven repository afresh. So you download any time, So you can have some caching options with this mount thing. And you can also specify directly the tag and provide a push directly from the Dockerfile. So when Rocker is running, you can tag it directly so you have everything together. So everything within the Dockerfile, you have not only the specification of the image, but also how it should look like when you build it. And it provides also some sort of templating, which is based on the Go template language. Here's an example of such a Dockerfile. So you have here a from. You have here two froms. One is simply from a Golang builder image. In this, during the build, you run the Go compiler, and the Go compiler creates a binary called ball.o. And then you have here this export directive, and this can be referenced here directly in this import stuff. So what happens here is it's all running on the same workspace, let's say like that. And in that case, it's simply equivalent to an add of this image of this binary which has been created there. So that your final image has no Go compiler and has no things which are related to the build anymore. You simply have a really runnable image there. Yeah, the advantage is that it's it has extensions, and actually, if you read the blog post, which is the basic of this Rocker thing, so there was, as it is always, there's always a blog post, and someone describes some problems and solves it with an own open source project. It seems that really these extensions are really sensible in that way that it really solves real-world use cases. So it's not something invented some artificially, but it's really something they stumbled upon, and they found it quite useful to have this sort of extensions. It works, it feels literally like a little bit like a Dockerfile. It's backwards compatible, so a Dockerfile is a valid Rockerfile in that case. Yeah. Of course, the negative part is that it's a custom format you have to learn, and of course, if you start to use these features of Rocker, then you have a login into Rocker itself. By the way, who of you did know Rocker before? Okay, at least some hands. That's nice. Good. And do you use it also? No. Okay. Yeah. Okay, this was a thing based on Dockerfiles, and now we are again a different. So we switch angles again a little bit, and now we look at the point how we can really bring the creation of the Docker images close to the creation of the application itself. So normally you can do this with a continuous integration system. More on this later. But another thing is how you can really have both together, because it makes sense to create your Docker images when you create your application artifacts as well. Therefore, it would be good to have some good build integration, which means that you simply, from your build steps, you simply call Docker. Of course, you can simply always, from any build system, you can call out to external processes and call the Docker CLI. But there are better ways for integrate stuff into your build. Here's an example for Java builds. And in the Java world, Maven is at the moment still the dominant build system. And what I want to show you now in the next slides are some Maven plugins. They're coming from our team here. And we provide two different kinds of plugins for Maven. One is the Docker Maven plugin, and one is the Fabricate Maven plugin. I have to say that if you want to integrate your Docker build into your POM XML, there are multiple ways. Nowadays, there are around 16 Docker Maven plugins available on GitHub, so you have really the choice. Fortunately, only 4 of them are still active, or maybe 2. So you have the choice between 2 or 4. In the links section of the slide, I've done some sort of shootout which compares all these Docker Maven plugins, so you can simply check out what fits your needs the best. Okay, what does this plugin do? Yeah, of course, it builds images within a Maven build, so you can version also your Docker files directly within your Maven build. It also knows about the build information already given in the POM XML. So, for example, if you're using assemblies, or if you have, for example, property set, all these things can be reused in creating your Docker images. And also a good thing, maybe, yeah, it depends whether you need it or not. You don't need a Docker client on the side. So this plugin directly speaks with the Docker daemon over either the Unix socket or via TCP to the Docker daemon. So there's no client library required. If you're interested, the site here is on GitHub. And here's an example how it looks like. There are different ways how you can configure it. So there's one inline XML configuration which you can use. You can define one image, or you can also define multiple images. So you can give multiple images in one single POM XML. Give it a name. This is how it will be tagged. Then you have 2 sections, build and run. The build section simply again specifies how to build the image. This is and the content which goes into the images in this assembly XML, defined in this assembly XML. But you can also define and declare how you can run the image itself. This is quite nice if you want to do integration testing, because then you can also, for example, define here several other images like Postgres or other stuff which you need for integration testing. So you can start up your whole environment directly from your POM XML within Docker containers, which are also linked together. There are different ways how you can link all these containers together network-wise. Then you run your integration tests. and check it, and afterwards you simply throw away all the other stuff again. So it's very nice to create repeatable integration tests here. Because they are also isolated in themselves, so you don't have any, so you can run them in parallel without getting any port conflicts, and also you can, for example, use some sort of dynamic port mapping. In that case, it would be, when you start up the container, the port which is exposed by the image with 8080 is simply dynamically mapped to an arbitrary free port, and then put into this Maven property here, which can be reused then, for example, in the integration test. Okay, this was the basic thing, which this is good if you run with Docker alone. But we have something more, which is called the Fabricate Maven plugin. And this Fabricate Maven plugin builds on top of the Docker Maven plugin. Actually, it embeds the Docker Maven plugin, so the Docker Maven plugin itself isn't part of this Fabricate Maven plugin. And the main purpose for this plugin is to create some sort of Kubernetes and OpenShift descriptors to bring your application not only on Docker, but also on these orchestration platforms, Kubernetes and OpenShift. But this is not the point here, but it's also a nice side effect. So you can simply create automatically these all the stuff which you need to get them on these platforms. Again, it creates the image configuration from the build information found in the POM XML. And the nice thing is for us here that it has a zero configuration mode, which means you can create Docker images without any configuration. How does it work? So what you need to do is in your POM XML, you declare the dependency on this plugin. And then you have your application, and you maybe, if you have a Spring Boot application, you have there a Spring Boot Maven plugin. If you have Wildfly Swarm, you have a different dependency. And this plugin has if you use it like this way, in that way, it has a very opinionated way how you create images. So the plugin will check your POM XML, what kind of technology you are using, whether you're using Spring Boot, for example. It checks simply whether there are some Spring Boot dependency included. Then it knows how to start up Spring Boot applications. So if you run this Spring Boot Maven plugin, it creates your fetch jar, which you can start up directly. Then it knows that's a Java application. It knows it's a fetch jar. Then it chooses for you a base application from our set of base applications, so these base images which I have shown you in some slides before, and creates in Docker image all of this information. So it's very, very opinionated. It also checks, for example, in the application properties, where the port is, how it is exposed, whether it's port 8080 or you have chosen something different. Whether, for example, you have a dependency of Spring Boot Accurator, and then it creates a health check directive for you in the Dockerfile. So it's quite powerful for certain things. So for Spring Boot, Vertex, Wildfly Swarm, and a generic web application, it's quite nice way to get started. You have also the options to configure certain aspects of this plugin in this zero configuration mode, but of course it's limited. So if you have really more complicated needs or more advanced needs, you can switch over to a full-based XML configuration mode or even plain Dockerfile mode. So you can provide also Dockerfiles with, for example, parameters which are then replaced by other properties. But this is just, also this I want to simply to show that it's also quite useful for the plain Docker image case, not only for Kubernetes and OpenShift. Okay, what are the advantages? Yeah, the good thing, in my opinion, is really that you have self-contained build. So you have a build, everything is described in your own POM XML. You don't need anything. If you have a new developer, for example, on your team, you simply, okay, here's the POM XML, you need Maven, you need a Docker daemon somewhere, and then go. You don't need any client libraries. You don't need to set up your CI system for creating the images. So everything is contained in one single file. This is a nice thing, for example, to start up stuff. And you can reuse existing build configuration. So everything, the best example is the Fabricate Maven plugin, which is really quite aggressive in trying to find things within it. Of course, a problem is that it has, again, new configuration syntax. So, okay, you can use Dockerfiles, but to take full benefit of everything, you should learn a new configuration syntax. And of course, there are more than one way. So there are more plugins how you can do this. Good. Okay, sorry. So next step, so we hop to the next station. And now we are leaving the local part. So everything which I have shown you is simply happening on your developer notebook. So you run it, of course, you can run the build in your CI system, but you can also run it locally. And now we simply go to jump to some sort of services which create images for you. And of course, the most famous service in that respect is Docker Hub. And you can, Docker Hub first is a public Docker registry, so you simply can push images to Docker Hub and other can pull it from there. But it's also a nice feature like automated builds, and you probably all know what automated builds is. You simply configure in Docker Hub, you give it a URL where your source or your Dockerfile is, and then it triggers certain builds according to, it starts builds according to certain triggers. You can, of course, you can start it manually. You can connect some GitHub webhook with the build so that every time you commit into this repository where your Dockerfile lies, a new image is created. You can also update your image. You can, based on the build of another image, so you can really build up some sort of dependency graph there within the UI of Docker Hub. And of course, you can directly start also Docker builds direct by an HTTP post request, which is sent directly to Docker Hub. So this is nice if you want to integrate it from somewhere else. The nice thing, which this automated builds have existed since Docker Hub exists, but they also worked on it feature-wise. And there are some interesting things which maybe I hope I can know, maybe not so good readable. So, but I explain it. So the good thing is you can, of course, you can select the branch and the tag on your GitHub repository from where the Dockerfile should be fetched. But you can now also, for example, say, if I make a tag on GitHub, I can translate this one to a tag on Docker Hub for the image itself. So you simply have some sort of regular expression and say, okay, anytime I tag something which has only tickets, I simply tag it the same way on Docker Hub. So you can really not always push the latest one, but you can also really synchronize the way how you make releases on GitHub with images happening on Docker Hub. This is quite nice. So this is, which we also use for our images. Yeah, you see, this is an example from our base images here. Yeah, so the good thing is it's free. It's based on Dockerfiles. Everyone can use it. It's super easy to use. You simply have to click. You have to give some permissions for your GitHub repository. You have a lot of options how you can start this build. And of course, okay, it's only Dockerfile. Whether it's a problem or not, of course, depends on your use case. But I think this was not something new for you. Maybe some more alternative ways how to do Docker images also is via continuous integration. The most famous and mostly used integration CI system is Jenkins, of course, I think. It's fair to say. And Jenkins, of course, has some sort of Docker build integration. So you can simply integrate a build step in your Jenkins build and then it creates images. So this is something orthogonal to this build integration in your POM XML, but because you do it now from your CI. So you have your plain build, which does not know anything about Docker, and only your CI system knows about Docker. But then, of course, you lose this capability of self-containment. But there are also other continuous integration services out there. Most of them are sort of services like Travis or Circle CI, and all of them have nowadays Docker integrations. So you can easily create from your continuous integration service which you're using also Docker images automatically. I have here one example for Circle CI. So you have to switch on Docker as a service for the Circle CI. Circle CI is a continuous integration service which simply you put some Circle CI YAML in your root directory of your GitHub repository, and then also via webhooks is simply connected to the CI, and then anytime you make a commit or something like that, a new continuous integration build starts there. And here there's such a description language, and he says, okay, if you check in on master, then also do the following things for these comments, and then you see you have you can use shell scripting here, and also there's a Docker CLI command available for Circle CI, so you can simply call Docker and do anything which you want to do there. So this is simply scripting. Maybe some interesting point, if you do it like that way, is Circle CI simply really runs in some sort of TTY when it does this build. So if you do it without this extension here, about this one here, then your log files really looks quite ugly because of all this escape sequence for this progress bar when Docker build is running. And you can simply force it to use to not use a TTY by simply piping it into something like cut minus. So it's just a small trick how you can pin down to the console. Yeah, and the circle CI itself defines certain environment variables like the circle tag and CI pull request. For example, here I also want to build only an image when it's not a pull request. Yeah, because it's the build is always triggered also for pull requests you get. But of course, I want not to have my latest to be mirroring the pull request which I just have received. And then you get the circle tag here below. It simply says, okay, this is this is the tag which has been used. Okay, this is a very nice way, and so you can simulate automated builds with Docker Hub that way. So you can do it with Circle CI, you can do it with Travis. So it's also so you are quite independent now from Docker Hub, and you can also push to any registry. You don't have to use Docker Hub as a registry as well. So you can do this quite nicely. Yeah, the pro, of course, CI integration because of CI build. It's flexible. There are many options, but if you do it that way, you log into the system you are using, of course. Okay, now let's come to the last two stations. The one is called Google Container Builder. Who knows Google Container Builder? None yet. Okay, that's good. So at least something new, maybe. So Google Container Builder is a very new service from Google, from the Google Cloud platform. And it's still in beta, and Google Container Builder allows you to create Docker images within the Google Cloud. So you build within the Google Cloud your images and not directly against a Docker daemon. So it has a REST API which can be used for this thing, and I'll show you in a minute how this works. So it's all centered around so-called build steps. And a build step for Google Container Builder is simply also a Docker image, Docker container. And at the end, you will create images which are always stored in GCR, so the Google Container Registry. And you can use this then from either your Google Compute Engine hosts or from your Google Container Engine setup. So if you're using, for example, Kubernetes in the Google Cloud with Google Container Engine, then you can simply refer to these images. And here's an example. So you have, again, you have a description language, it's called Cloud Build YAML. And there we have steps. So we have here in this example that's only a single step, but of course there can be multiple ones. Then you specify a certain image, which is simply the type of your builder step. In that case, it's a Docker image which simply runs Docker itself. So it's something like Docker and Docker, or maybe also, you can simply run Docker within these images in this container, and then you give simply the argument there. And the argument is given to the container, and then in that case, Docker is run and creates a new image, which is called like that. And then you have a final images variable, which simply says, okay, no problem, can leave it. And so it simply said at the end, so we have several build steps, and they create so you can have a second step which also creates a different image, and so can create many images. At the end, you simply say the images which has been created during this build run should be exported to the Google Container Registry. So this list only says everything other should be ignored. I only want to have these images at the end in the registry. So then a push happens of the local image then back to the registry. In order to use Google Container Engines, you need either the Google Cloud SDK. So this comes with some tool. It's called gcloud, which is a Google Container CLI tool. Or you can, of course, use the REST API, for example, with curl or some client library. Maybe I have some more. No, I have not. Okay. There are some examples of the step images. You can always write your own step images very easily. So you only what to do is to have to provide some sort of Docker image, referred with this step directive, and then you get some arguments, and then you can do something. There's also a working directory which is volume mounted within your container. So everything which is in this directory can be shared across these container steps. And there are also some sort of predefined build steps coming from this build service. So you have Bazel, which is Google's own build tool. You can, for example, check out something from Git. This is then stored in this working directory, and then you can run this Docker step to create an image from the stuff which you just has checked out from Git. So you can change that one. So it's a very easy way how you can define your your images, and you have, as you can see, there are multiple steps which you can use here. Okay, then what's the good thing is, of course, that there are various, of course, super perfect integration in the Google Cloud platform, so everything is set up with your security things. You can refer to the Google Cloud storage for getting things and so on. So everything is, of course, perfectly integrated. You have still full access to all Docker features, which is not so, not so evident from the beginning, because normally if you have a cloud service like that, it's a little bit restricted with respect to Docker. It's quite easy to use. You only have to write this YAML file with all the steps in between. On the negative side, it's still better. And again, it's not so super useful if it's not running in GCE, of course. Yeah, because it's so thing. But at the end, if you simply want to have an image in the Google Container Registry at the end and refer this one from the outside, you can still do this, of course. And as far as I know, it's still a free service, so you can use it without any fees. Okay, now let's come to the last point. This is OpenShift S2I, which who of you knows OpenShift? Okay, that's good. And S2I also, okay, one at the end. So maybe I can tell you again something new. So first of all, some words on OpenShift. OpenShift is a so-called PaaS, Platform as a Service platform, which can be used in different flavors. So there is an open source variation. It's called OpenShift Origin. There is the commercial offering, which is was called OpenShift Enterprise, but it's called OpenShift Cloud Platform, I think, nowadays. So they have some sort of pardon? Container platform. Sorry, I should have known, but yeah, maybe. Okay, container platform. So I typically work with Origin at the moment. And then there will be soon that a public offering is called OpenShift Online. You can already register for it and use a developer preview for that one, which provides all the OpenShift facilities directly hosted for you. OpenShift Enterprise is something, OpenShift Container Platform is something which you can simply install on-premise at your company, and you get all the full support as you are used to from Red Hat, support, documentation, and so on. And finally, there's something called OpenShift Dedicated, which is the platform which is also hosted by Red Hat, but only for your company. So it's not something like a public offering like OpenShift Online, but really something, some private installation there. Okay, and OpenShift, as I said, is a platform, and it's based on top of Kubernetes. So it's also all about orchestration of containers, Docker containers in that case, and it adds some additional value on top of this. So Kubernetes itself claims to be more or less a container as a platform service, container as a service. Yeah, so that it's more about the operation of containers, whereas OpenShift also adds the so-called build aspect to the platform, so that you can do builds within this platform. So the most prominent way how to do this is called source to image, and for source to image to use, it's quite easy. So you simply provide OpenShift a link to the source code itself, and then you select some sort of builder image, and OpenShift simply brings both parts together. And then the builder image starts and fetches the source there and then creates the executable out of this one. Here's an example. So this also, if you have an OpenShift instance, by the way, it's nowadays quite easy if you use Minishift. So in Minikube, this is really a one-stop command to create a single node OpenShift cluster on your notebook. It's super easy, so it's highly recommended. So if you have some OpenShift installation, they have your client tool. It's called OC in that case, and you call it like this one, that you have new app for creating a new application, and then you provide these two pointers. So you see that there's a tilde in between. So you have first you give the builder image, and then some reference to the source. The source, by the way, can also come, of course, from the local file system. It doesn't have to be in some Git repository. And you can also, OpenShift also provides some sort of a facility to automatically detect builder images based on the content of the source. So for example, if it finds some sort of POM.XML, it knows it should be a Maven build, and then selects for you some builder image. Of course, these builder images must be available already within OpenShift or in some registry. So what OpenShift now does, it simply starts this builder container, in that case this Ruby image. It checks out the source from GitHub. and then runs the build. So there are some certain scripts within the builder image which are called now. So one of them is called assemble, user local sti assemble. And this assemble gets as argument the local directory of the source code within the container. And then depending on the builder image, of course, this assemble script creates something. In the Maven case, for example, it runs Maven based on the POM.xml. And and does all the stuff. At the end, you have your jar files. And then this assemble script copies it over into some other dedicated directory. And when the build is run, it simply stops the container, of course, and commits it to a new image. And this one is now your application image. So in the OpenShift case, you have your application contains all the building stuff as well in the application image. This is normally not that big problem because typically you can, if you use it for Ruby or for any other interpreted language, there's not much thing which you need for building things. It's simply putting things together and starting it up, like PHP or Ruby or something like that. So there's no compile step like that. For Java, it's more complicated because there you should, the assembly script also takes care that, for example, the Maven repository gets cleaned up after the build and other things, because otherwise all your Maven dependencies and all your stuff also ends up in the application image. But this is also the drawback for things like Java is, of course, that the build time. Because every time, if you do it naively, and every time you start this build, then every Maven dependency gets reloaded afresh. So if you don't have some sort of Nexus setup behind, some sort of proxies or some repositories, this is quite a big problem. There are a solution for this which we are working on. This is called so-called binary builds, where you do the build outside of OpenShift and only provide the jar file to the builder image, and then the builder image simply takes the jar file and executes it. So there's no build step in between. This is also quite easily possible with OpenShift S2I. But again, this is a different philosophy. So there the build happens outside, so you need some sort of infrastructure for creating the build. With the regular S2I thing, the build happens inside OpenShift. And then when the container is committed to an application image, then this app container is started, and then your application is running. Within OpenShift, with all the benefits you have for OpenShift, that you have internal registry, you have also single sign-on facilities, you have a lot of image stream automatic updates. So within OpenShift, that you say that you can build up some sort of chain between image streams, and if one image stream changes, then you can simply recreate all the other images. So this all works quite nicely within OpenShift. And source to image is one of the aspects which is happening in OpenShift. So what is the advantage of this approach? So one of the things is that it's really quite secure because there's no Docker daemon involved at all which you directly can contact. So it's only the builder image which is running, so you never run a build in some sort of root context. And this was also the main reason for doing source to image for OpenShift, because OpenShift is designed as a multi-tenant platform where a lot of things happens in parallel for a lot of different parties. And there it's very important that really these builds are very, very secure. And also when you run your application, for example, with source to image, a random user ID is chosen. So your applications never will run as a root user. It's still easy to use, so if you have some simple applications, there are a lot of examples out there, so you can easily try this out as well. Of course, the possibilities are limited to the possibilities of the builder image. So if the builder image doesn't support a certain thing, like, let's say, like adding some sort of extra configuration, then you're lost, or you have to write your own builder images. For Java, as I said, source to image is quite slow. Yeah, and finally, of course, this only works for OpenShift. I think this is evident. Okay. So now we are at the end. I hope you have a lot of points. We have still 5 minutes, so maybe we can even be the first at the lunch. That's good. But let's wrap it up. So what I wanted to show you in this talk is that Dockerfiles are really okay. They're really okay. There's no big problem, and in most use cases it really works out very well. So it's not something that I'm against Dockerfiles or so. But at some use cases, they are limited. So, for example, if you want to reuse certain things, if you want to create many similar images like that, then there have certain limitations. And but luckily, there are a lot of alternative ways how you can create Docker images, and I'm pretty sure this is only a subset of that what is out there. So probably there are probably many more things what you can do. But I'm pretty sure that for any use case you will find a certain way how to do it. And of course, you should pick the one which fits best your use case. Okay, that's it. So I'm at the end. Are there any questions? Oh, okay. There's a question, yeah? Yeah, there are 2 ways how you can do this. So you can use Docker in Docker, where you really start a Docker daemon within your Docker container. This is possible. And the other one is that you simply mount the Docker socket, Unix socket, from the outside within the container. So you simply, I like to call it the wormhole pattern, because you simply call the Docker daemon which has created yourself. So you mount the Unix socket within the Docker container, and then you can operate on the parent Docker daemon. This is a way how people do, but there, of course, you have some limitations. It must run as a privileged container and something like that. Okay, so then, thank you, and have a nice day.